Good afternoon. My name is Muhammad Farouq Nashran bin Muhammad Iskandar, and today I will be presenting about my ebook titled Waste Reduction by Design, where I explore about how thoughtful design consideration, especially through design for disassembly, can minimize waste and support sustainable development. In the construction industry, waste is a major environmental issue. Buildings are often demolished at the end of their life, sending tons of material to landfill. But what if we could design buildings differently so that they could be taken apart, reused, or relocated? That's where design for disassembly or DFD comes in. These ebooks aim to explore how DFD can be used as a strategic design approach to reduce construction waste and promote sustainability from the start. Now, before we jump in further, I will explain about DFD or Design for Disassembly. Design for Disassembly or DFD for short is a sustainable construction design technique that make it easier to disassemble structure or parts of the building at the end of their life cycle so that the material can be recycled, repurposed, or reused rather than ending up in a landfill. Now, why I choose DFD as my technology and innovation strategy is it is a proven strategy for reducing waste in construction by encouraging reusability and resource efficiency. And it can also be integrated with modern technologies like BIM for better planning and life cycle tracking. Through my research, I found that DFD has great potential. It significantly reduces waste and emissions, cut costs over the building life cycle, and creates local job opportunities in reconstruction and reuse. Studies also show that reusing building materials can reduce environmental impact far more than recycling alone, with some projects reporting up to 88% with lower carbon emissions. Now, let's take a look at the benefits and challenges of DFD. Design for the assembly offers several important benefits. First, it helps reduce construction and demolition waste by allowing components to be reused rather than discarded. Second, it lowers the long-term cost by minimizing the need for new materials and reducing landfill fees. Finally, it supports flexible and adaptable building designs which can change over time without needing full demolition. Overall, the DFD encourages a circular economy approach in the construction industry. However, despite its benefit, design for this assembly face a few challenges. One of the main barriers is the lack of government policies or standards that promote DFD. Many professionals don't have guidelines or incentives to apply it in real projects. Another challenge is public perception. Many people still believe that reused materials are poor in quality, and the market for salvaged material is not yet strong. Next, I will talk about how to overcome the challenge that I just mentioned. To overcome these issues, first thing is government intervention is crucial. By introducing policies, tax incentives, or green certification points for DFD-friendly buildings, authorities can encourage more adoption across the industry. At the same time, public education campaigns should be launched to showcase the success of reuse-based construction and raise awareness about the quality and safety of reclaimed materials. Together, these actions can shift both professional practice and public attitudes toward more sustainable building methods. To see the design for this assembly in action, I studied the NETC Discovery Center in Canada. This modular building was designed for disassembly principles, using prefabricated panels and mechanical fasteners. After its first use, the entire structure was disassembled in 6 days and reassembled at a new location. Over 99% of materials were reused and emissions were significantly reduced, proving that design for this assembly works in real-world projects and not just on theory alone. The project also aligns with several UN Sustainable Development Goals, which is the first one being SDG 11, Sustainable Cities and Communities, SDG 12, Responsible Consumption and Production, SDG 8, Decent Work and Economic Growth, and lastly, SDG 9, Industry, Innovation and Infrastructure. These goals highlight the importance of reducing waste, promoting innovation and supporting green jobs, all of which Design for this assembly directly contributes to. To promote design for this assembly in the construction industry, I recommend 5 actions. First, start with early integration of DFD at the design stage, and then add DFD training into education and professional development. Also, government should also offer regulatory and financial support. This is to strengthen the reuse market through public campaigns and better the infrastructure. And lastly, invest in innovation, digital tools, and modular systems to make DFD more efficient and scalable. In conclusion, design for this assembly is a powerful solution for reducing waste and building more responsibly. As shown in the NetC Discovery Center, design for this assembly allow us to rethink how we build, not as something permanent to demolish, but something flexible and reusable. It supports long-term sustainability and aligns with major global goals. If adopted more widely, the FD could help transform the construction industry into a truly circular and low-impact system. Thank you for your time and attention. I hope this presentation helped you see how waste reduction can start with designs.